this YouTube video. And in this video we're going to be looking at solutions to differential equation, and on this particular video we're going to be looking at how to solve the base form of homogeneous differential equations. How do we solve the base form of homogeneous differential equations? Alright, so we're going to look at this question. Alright, so we have in bracket 2xy plus x squared, then we have dy dx is equal to 3y squared plus 2xy. So now what's the difference between an homogeneous equation and an equation that is solvable by separation of variables? Well, that question is very simple. The thing is, you can try, when you're being given a question, try to separate the variables. If you cannot separate the variables, then you should use homogeneous equation method to solve it. Now if you look at this question, you can see there are parts of this question where you have 2xy, right? So we have x and y together. Now if we say we should divide through by x, we are still going to have x with y, right? So this is not possible to completely eliminate x from y in this question, right? So then we're going to be using equation solvable by homogeneous equation to solve this question. So basically the form that you are looking for homogeneous equation is dy dx is equal to f x comma y and theta x comma y, right? So when you can get the question in this form where you have a value of xy at the top and a value of xy at the bottom, and then you have it equal to dy dx, then you can use this method, right? So very quickly, what we're going to do now is that we are just going to be dividing both sides by 2xy plus x squared, and the reason why we are doing that is so that we can get dy dx to be alone. So we have 2xy plus x squared over 2xy plus x squared. So we have this, will cancel out this, and then we have dy dx is equal to 3y squared plus 2xy over 2xy plus x squared. So now if you look at this equation that we have on the board now, you can see that it fits perfectly into this form that we are looking for, right? This homogeneous form, right, where we have a value of f with xy and 1 with xy at the bottom, right? We can see it here, we can also see it here. So once you have it in this form, then you are good to go and you can start solving, right? So now the idea behind homogeneous equation is that we're going to be using substitution. We're going to substitute a value, right, so that we can eliminate these variables that we have two together, right? And the reason why we are eliminating the variables that have two together, is so that we can have just one variable. We want to have each variable standing on its own, right? So we're going to say let y equal to vx, right? Is a constant, right? You must always let y equal to vx, right? You can decide to use another variable if you want. You can say let y equals to bx, but y must be equal to something times x. And now we're going to substitute the value for y. So we're going to have dy dx is equal to 3. Wherever we see y, we're going to put vx, right? So this is going to be v squared x squared plus 2x squared v, right? Then we have over 2x squared v plus x squared. Now if you can look at this equation, you see that something is common. We have x squared with all of them, so meaning we can factorize x squared out. So we have dy dx is equal to x squared into the bracket of 3v squared plus 2v. Then we have all over x squared into the bracket of 2v plus 1, right? So x squared, we cancel x squared here, and then we're going to have dy dx to be equal to 3v squared plus 2v over 2v plus 1. Now if you look at this question, you will see that now we have eliminated two of the variables. We have just b in this question, which is going to be simpler for us to solve. But now the problem lies where we have dy dx and then we have b, right? These are two independent variables that have nothing to do with v, so we have to find a way to replace dy dx with a variable or an independent variable that has something to do with v, right? And we can do that very simply. We can just find the derivative of y is equal to vx, right? Once we find the derivative of this, then we can now substitute the value of dy dx into the question, right? So now if we find the derivative of y, it's going to give us dy dx, right? Whenever you take the derivative of y, you almost always add dy dx. then is equal to the derivative of v multiplied by x. The derivative of v multiplied by x is going to be dv dx. Then multiplied by x is going to be x dv dx, and then we're going to take the derivative of x multiplied by v. The derivative of x with respect to x is 1, multiplied by v is v, so that's plus v. So now we have seen that dy dx here is equal to x dv dx plus v, so we're going to replace dy dx with x dv dx plus v. And the reason why we are doing this is so that we eliminate y, because we don't have y as a variable in the question again, and we need just 2, right? So if we have x dv dx plus v is equal to 3v squared plus 2v over 2v plus 1, then we have only the variables of x and v in the question, and then it is easy for us to just solve, right? So what we're going to do now is we're going to replace that variable. So we're going to have x dv dx plus v is equal to 3v squared plus 2v over 2v plus 1, right? So we have this, and now we are going to take this v to the other side, so we begin simplifying the expression now. So we have x dv dx is equal to 3v squared plus 2v over 2v plus 1 minus v, right? Let me rub this part off so that we can have an ample amount of space to solve. All right, so now all right, where are we? So we have x dv dx is equal to, now we're going to combine these fractions together. So we have 2v plus 1, here we have 3v squared plus 2v, and then we have minus v times 2v, so that's going to give us minus 2v squared. Then we have minus v plus 1, we have minus v, and then we simplify. So we have x dv dx is equal to v squared minus v over 2v plus 1. Yes, all right, so we have that. Okay, so this is 2v minus v is going to give us plus v, right? So we have this now. So now what we can do now is, now we can now separate the variables, right? All the variables that have v, we want to take them to v, and all the variables that have x, we want to take them to x, right? And then we just use the method in equation solvable by separation of variables to solve this question. So we're going to cross multiply here. So cross multiplying now, we have 2v plus 1 multiplied by x dv is equal to v squared plus v multiplied by dx. Now we want this x to be on this side, and we want 2v squared plus v to be on the other side. So we're going to divide by x multiplied by v squared plus v for both sides, right? X multiplied by v squared plus v. So this v squared plus v will cancel this x here will cancel this. So now we're going to have 2v plus 1 over v square plus v dv is equal to 1 over x dx, and then we take the integral of both sides. So now we can see that it's looking more like the equation solvable by separation of variables. So the entire idea of this particular method is that whenever you have xy, right, you have two variables together and you cannot separate them, you're going to apply this method, right? So you introduce a new variable for y, then after introducing the variable for y, you are going to substitute that variable, and then you're going to simplify it, right? You simplify the expression, you take the derivative of that substitution for y equals to vx, and then you substitute that, you simplify your equation, and then you should just be having just two variables in the question, and then you can now use equation solvable by separation of variables method, that's integrating both sides and adding plus c to the side that you have your x on, right? So I'm going to clean the other part of the board. Alright, so now we can now solve this question. Right, so we have 2v plus 1 over v squared plus v. Yes, we have over that. So now what we're going to do in this one now is, because we have over, so we're going to be using integration by substitution, right? So we're going to say, so I'm working on the left hand side now, so we're going to say let v squared plus v equal to b. I don't want to use u so that it is not confusing. So then db over dv is equal to 2v plus 1, right? 2v plus 1, and then we'll make dv subject of the relation. So dv is equal to db over 2v plus 1, and then we can substitute back into the equation. So we are going to have 2v plus 1 over b, right? Because v squared plus v is now b, then times dv, okay, sorry, db over 2v plus 1, right? We already substituted dv to be db plus over 2v plus 1. So 2v plus 1, we cancel out 2v plus 1. This is equal to 1 over x dx plus c. So now we have the integral of 1 over b db is equal to the integral of 1 over v d, sorry, this 1 over x dx plus c. And now we can now solve when the integral of 1 over b is going to give us ln b, and this is going to be equal to ln x plus c, right? So we have this, and then we can now simplify this question. So what we can do here is we can take this one to this side so that we can now join them together, right? If we take it to the other side, we're going to be having a negative sign, and you know, for logarithm, whenever you have a negative sign in between the in between two logarithms, you can divide them with each other. So we're going to have ln b minus ln x is equal to c. So we have ln b over x is equal to c. And now to eliminate the lateral log, we're going to take the exponents of both sides. I already explained why we are doing this in equations solvable by separation of variables. And then the e, we cancel the natural log, so we have b over x is equal to c. Right, now we cannot leave our answer like this, right? Because b was not in the original equation, neither was x. Now we're going to substitute a value for b. B is 2v plus 1, sorry, b is v squared plus v, then we have over x is equal to c. And now remember that we also substituted a value, right, for y, because v is not also in the original equation, right? So we have to also eliminate v as well. So remember that y was equal to vx, so we can make v subject of the formula. So v will be equal to y over x, and then we substitute y over x in this question. So we're going to have y squared over x squared plus y over x, then everything here over x is equal to c. And basically at this point you're just simplifying. There's nothing too stressful. You just need to simplify the equation that you have on the board, and then you're good to go. So what we can do now is to combine the fractions, right? So we're going to combine y squared over x squared plus y over x. So combining that, we're going to have y squared plus xy over x squared, then is equal to cx, right, after we cross multiply. So we have this, and then we can also cross multiply at this point. So we're going to have y squared plus xy is equal to cx cubed, and this is going to be your final answer for this question. So very simple. You just follow the steps. The first thing that you do is check if you can separate the variables. If you cannot separate the variables, then you're going to make it in the form of dy dx is equal to fxy over theta xy, and then after you have done that, you're now going to introduce a new variable y equal to dx. You differentiate that variable, and then you substitute, and at the end of the day you end up with an equation solvable by separation of variables. You integrate both sides and you add plus c to both sides. We're going to take one more question on this. Alright, so now for this question, let me change this. We have y squared minus xy dx plus x squared dy is equal to 0. So you can pause the video at this point to try to see if you can get the answer to this question. Alright, so now for the first thing here is that we can see that we have xy, so separating this question is going to be very difficult. So one thing that we can do is just take this dx to the other side first, right? So doing that, we're going to have x squared dy is equal to negative y squared minus xy dx, right? So we have this, and now what we're going to do is divide both sides by dx and divide both sides by x squared. Don't forget the form that we are looking for is dy dx is equal to f x comma y over theta x comma y. This is the form that we are looking for, right? So dy over dx has to be there first. So to do that, we just have to divide both sides by dx, right? So if we divide both sides by dx and divide both sides by x squared, so that we eliminate this x squared that is here, right? So that's the logic. So this x squared we cancel this x squared, dx here we cancel dx here. So there we have dy over dx is equal to, I'm going to use the negative sign to multiply through, so I'm going to have xy minus y squared, right? So I'm just rearranging it, because if you use negative 1 to multiply y squared, you have negative y squared, and if you have negative 1 to multiply xy, negative xy, you have positive xy. So I'm just rearranging it so that negative sign does not start the equation. So I have xy minus y squared over x squared. So now I have this, right? And now we can see that it is looking very much like this form. So what we do at this point now is introduce our variable, substitution variable. So we have y is equal to vx, right? And then we should differentiate. We have dy dx is equal to v, we have v plus x dv dx, right? We have this. I'm just doing it this earlier on so that we do not have to go back and forth when solving. So now we're just going to substitute this value for dy dx. So I'm going to have v plus x dv dx is equal to xy. Remember, y is dx, so substituting the value for vx, we're going to be having vx squared minus y squared, which is going to be v squared x squared, then we have over x squared. Now x squared is common in all three of them, so what we are going to do at this point is just factorize x squared out, and then we cancel it out, right? So we're going to have v plus x dv dx is equal to x squared in the bracket v minus v squared all over x squared, right? So we have that, and what we're going to do now is that we're going to cancel out the x squared, and then we're going to take this v to the other side. So we're going to have x dv dx is equal to v minus v squared minus v, right? We're going to have that, and at the end of the day we're going to have x dv dx is equal to minus v squared. So we have this, and we're going to now solve this question. And how we solve it now is that we're going to now separate the variables, right? So the moment you get to the point where you have just two variables, right, you have dv dx and you have x and v, then you can now solve. We don't have any variable together, we don't have any variable like xv, and we don't have a third variable y in this question. You just separate the variables, and then you apply the method for equation soluble by separation of variables. So now we're going to cross multiply, right? So we're going to have x dv is equal to minus v square dx, and now we know we want v to be with v dv, and we want x to be with dx. So what we do now is just divide both sides by x times minus v squared, right? So that the x here we cancel x here, and the minus v squared we cancel the minus v squared here. So we have 1 over minus v squared dv is equal to 1 over x dx, and then we take the integral of both sides, adding plus c to the side that x is on. So now we're going to now integrate 1 over minus v squared, which is the same thing as minus v raised to the power of minus 2, and if we should integrate that, we are going to be getting 1 over v. We're going to get 1 over v, and then equal to the natural log of x plus c. So basically for this question now, because 1 over v does not have natural log, so we cannot join them together, right? So what we're going to do is just replace the value for v, and we know that y is equal to vx, so that means v is equal to y over x, so that means 1 over v will be equal to 1 x over y. So we're going to have x over y is equal to the natural log of x plus c, and this is your final answer, right? This is your final answer. Now in some questions, instead of using natural log, some lecturers might decide to use log, right? So your answer could come like this: x over y is equal to log x plus c. They mean exactly the same thing, it just depends on who is teaching, who the lecturer is, or who wrote the textbook. So they are exactly the same thing, and this is the answer to this question. And this is how you can solve equations, homogeneous equations, equations of this type, right? Equations that you cannot separate the variables. So you're going to use this method to solve them.